Hello everyone, my name is Sudheer Kumar, working as an assistant professor of mathematics, MLR Institute of Technology. In this lecture, I am going to cover double integrals and change of order of integration. Changing of order of integration in double integrals. Let us see. By changing the order of integration, evaluate integral 0 to 1, integral 0 to under root of 1 minus x square, y square, dy dx. Last lecture we have seen how to change the order of integration and evaluate the double integral, right? You can observe when both x limits and y limits are given as 0. So first of all, write down what is given in the question, then let us see the graph of both x and y curves. So 0 to under root of 1 minus x square means these are y limits. So y limits are given as 0 to under root of 1 minus x square and x limits are 0 to 1. We have to change the order of integration, means x limits given as constant. So after changing the order of integration, y limit should be constant and x in terms of y. So let us draw the curves y equal to 0 and y equal to under root of 1 minus x square. So y is equal to under root of 1 minus x square is the upper limit. That means if you squaring on both sides, y square equal to 1 minus x square. So that implies x square plus y square equal to 1. So this is the circle equation of radius 1. So this is the x-axis. So this is 0 comma 0. This point is 1 comma 0. This is y-axis. So this is 0 comma 1. Right. Now the region of integration, in which quadrant or in which area, what is the region of integration, that we have to identify. Then we can see easily limits for x and y. We can observe both x and y limits are having lower limit 0. That is, the region of integration is in first quadrant, right? In this, we have to find x limits in terms of y to change the order. So to change the order, of integration, so given y in terms of x, we need to write x limits in terms of y. For that, draw a horizontal line or a horizontal strip in the region of integration. So let us draw a horizontal line or a horizontal strip. One end of the line touches this y-axis, that is lower limit. Another end of this horizontal line touches this circle equation, which is x square plus y square equal to 1. So another end of this strip touches this circle. Therefore, lower limit is nothing but x equal to 0 and upper limit from this equation, if you write x value in terms of y, we get under root of 1 minus y square. So after changing the order of integration, x varies from 0 to under root of 1 minus y square, and we have to write y limits. So this is a, this is b, this is origin. From the point O to A, we can observe that clearly y varies from 0 to 1, right? So 0 to 1, 0 to under root of 1 minus x square, y square dy dx. This can be written as integral 0 to 1, 0 to under root of 1 minus y square dy dx. So x limits are in terms of y. So let us integrate this first with respect to x, then with respect to the constant limits y. So x is equal to 0 to under root of 1 minus y square dy, sorry, dx, then dy. First let us integrate with respect to x. So this is can be written as y is equal to 0 to 1. So integration of y square dx is y square into x, for x limits are 0 to under root of 1 minus y square, now dy. So integral y is equal to 0 to 1 y square into, in place of x write down the upper limit, y square dy. So let us write y is equal to sin theta, dy is equal to cos theta d theta. So let us convert this from Cartesian to polar. So theta is equal to, if y equal to 0, what is theta value? Sin theta 0 means theta value 0. If y is equal to 1, substitute y equal to 1 in this equation. So sin theta value will be 1 if theta is equal to pi by 2. So this integral can be written as theta equal to 0 to pi by 2. These are the values of theta, right? Y square means sin square theta, under root of 1 minus y square means under root of 1 minus sin square theta, dy means cos theta d theta. So this integral can be written as integral 0 to pi by 2 sin square theta into under root of 1 minus sin square theta is cos square theta, root of cos square theta is cos theta. So cos theta into cos theta is cos square theta d theta, right? So to evaluate this integral we can use beta gamma functions, or we can apply direct formula. We have integral 0 to pi by 2 sin power m theta cos power m theta d theta, where m and n both are even. Here m is n value 2, both m and n are even numbers. So with the help of this we can write this as sin power m theta cos power n theta d theta. If you integrate this, we can also write this as integral 0 to pi by 2 sin square theta can be written as 1 minus cos 2 theta by 2. Similarly, cos square theta can be written as 1 plus cos 2 theta by 2. In that one also we can evaluate this integral, or directly we can, if I integrate this, we will be getting pi by 16, right? Let us see next problem. By changing the order of integration, evaluate this integral 0 to 1, integral 1 to 2 minus x. First let us write what are x and y limits. So given limits are y is equal to 1 to 2 minus x and x is equal to 0 to 1. So these are the limits for x and y. First let us draw the graph. X equal to 0 means y axis, x equal to 1 means this line, y equal to 1, y equal to 2 minus x. So this is origin. Okay, let us write neatly. So y equal to 1, this is the line, y is equal to 1, y equal to 2 minus x is this line, y is equal to 2 minus x. So this point of intersection, this line represents x equal to 1 and y axis is x equal to 0. This is y axis. So this is origin 0 comma 0, this point, this is 1 comma 0, this point 2 comma 0, this point is 1 comma 1, this point is 0 comma 2, right? So let us label the values. This is 0 comma 1, this is A, this is B, C, D. Now we have to identify the region of integration, in which area the common area between these four lines exists, that we need to identify. So between the line y is equal to 1, y equal to 2 minus x, x equal to 0, x equal to 1. So this is the common area, that is region of integration. So this is the region of integration between the four lines. Now we have identified the common area, that is region of integration. Now to change the order of integration, we have to write x limits in terms of y and y limits as constant. So to change the order, of integration, first to write x limits in terms of y, what we do to change the order of integration? Draw a horizontal line which is parallel to x axis. Draw a horizontal line which is parallel to x axis in the region of integration, where we have to draw the horizontal line in the region of integration. So first let us draw a horizontal strip or a horizontal line in this region. So one end point touches y axis, another end point touches the line y equal to 2 minus x. So in this I want x limits. So this is the upper limit. So what are the limits for x? X equal to 0 to, so after changing the order, of integration, x equal to 0 to x equal to 2 minus y. So x equal to 0 to x equal to 2 minus y. These are the limits. And what are the y limits? We can see this is the coordinate A 0 comma 1 and this is the point B 0 comma 2. So if you can see the limits for y between the points A and B, we can see that y coordinate changing from 1 to 2. So y varies from 1 to 2. So therefore integral 0 to 1, integral 0 to 2 minus x, xy dx dy. So this can be written as, after changing the order, y is equal to 1 to 2, x is equal to 0 to 2 minus y, xy. First we integrate with respect to x, then with respect to y, right? So this can be written as y equal to 1 to 2. What is integration of xy dx? That is x square by 2 into y, and the limits are 0 to 2 minus y. So this can be written as y is equal to 1 to 2. In place of x, let us write down the upper limit, 2 minus y whole square by 2 into y dy. So this is equal to y equal to 1 to 2 y into, so this 1 by 2 let us write it outside. In place, let us expand this using a minus b whole square, a square plus b square minus 2ab, that is minus 4y dy. So if you integrate this 1 by 2, y is equal to 1 to 2, 4y plus y square into y is y cube minus 4y square dy. So this is equal to 1 by 2. What is integration of 4y dy? Y square by 2 plus y cube integration is y power 4 by 4 minus y square integration is y cube by 3. Now substitute the limits 1 to 2. So in place of y, first let us substitute upper limit 2 and then upper limit 1. So if we solve this, we get 5 by 24. Thank you.